Well, our keynote speaker is already in the stage, but it's a great pleasure to receive you here, John MADDOG Hall, and it's always a pleasure to receive you. Thank you for coming.
Thank you, Roseli. Hello, everybody. I would like to thank the committee for inviting me. I did not really know I was going to be able to make it here until last week, because on May the 8th I had a heart attack, and a week later I had another heart attack. And my doctor kept saying, I don't know if you can travel, but he let me, so that's nice. My talk tonight is about bringing more innovation to Brazil. And I say more innovation because I think Brazilians are very innovative. But you are hampered by something which I will hope to show you and see what the solution is. Often you have to stop back and look to see why things happened. And Linux and free software in specific happened because in 1984, Richard Stallman was a student at MIT, and he was trying to get a printer to work with a binary-only operating system. And he couldn't do that, and he was infuriated because he owned the printer and he thought he owned the operating system, and he still couldn't make it do what he wanted it to. And so he started the GNU project, which stands for GNU is not Unix. And he started writing software, but he was very smart about something because he didn't start writing the kernel of an operating system. Instead, he started writing software that was useful across many different operating systems. And of course, the first piece of software that he was most famous for was Emacs. A lot of people think he could have stopped with Emacs as a whole operating system, but that's a different story. And then other projects happened, like the X-Window system from MIT, Project Athena, and other pieces of software happened. But these were all pieces of software that could run across various operating systems. Why? Because at that time, it was still very expensive to get a whole computer system to make an operating system on, versus you could work on software that went across many operating systems and have it be useful. So by 1991, the last piece of the operating system was kind of missing, the kernel. And at that time, what happened that allowed that kernel to be written? Well, number one, the internet started to come into people's homes. It wasn't just in companies and universities, but by coming into your home, when you went home at night, after a hard day of programming at work, you could work on this other program, the one you really loved, the kernel project. And so people were able to work on that. And the second thing that helped out with that was that there was a large amount of information available on the internet and from books on how to write an operating system. And finally, the drop in computer prices for very powerful computing systems. If you remember, up to that point, the Intel 286 processor was still relatively expensive, and it had one fatal flaw, that it was only really able to support a swapping style of operating system, not a demand page virtual memory operating system. And that happened with the 386. But 386, when it first came out, was still kind of expensive. So as the price dropped, and as the 386 became older, people would then be able to use a 386 on this strange project of writing an operating system kernel. And so the final piece came into place. A very stubborn student at the University of Helsinki named Linus Torvalds, and the Linux kernel project was started. So all of these things came together like a perfect storm. I'm going to introduce you to a few of my friends who I've met over the years. None of these people are very famous like Mark Zuckerberg or Steve Jobs or anything like that. But the person up in the upper right-hand corner was one of three people that started a small software company down in Raleigh, North Carolina. He was a college student. I didn't really study computer science. He was a history literature major, but he happened to like writing programs. He happened to like computers. His name is Eric Troen. He started Red Hat Software, and he's now a multi-millionaire. I remember telling Eric he was going to be worth a lot of money. He goes, no. He said, no, it's never happened. And yes, it will. That guy right there was a college student who was running a support organization out of his dormitory at university. He said, I need a piece of equipment, a telephone system called a private branch exchange to help me run my services better. But a private branch exchange would cost between 20 and 30,000 US dollars. So he said, I'll write my own. How difficult could it be? And he wrote a piece of software called Asterisk. And today, Asterisk is installed in tens of thousands of businesses around the world, reducing the price of a private branch exchange system to around $500 and much more flexible. His name is Mark Spencer, and he is worth about $383 million. This person right here, oops, this person right here is not a multimillionaire, but he started writing code at the age of 15. By the age of 18, he was being paid by his father's company $40,000 a year to write device drivers. He later went on to help to create some of the next special awards for special effects for Star Wars. And now he's living out on the West Coast doing PhD work for the University of Washington. Did I mention he never graduated from high school officially? This person right here created a distribution that installed into the FAT file system of Windows so that you could boot it and run it without having to repartition your file system. He had sold 20,000 copies before his parents found out what he was doing. And when they said to him, why didn't you tell us you were doing this? He said, well, I really didn't need your help. This person down here is from Soweto, South Africa, a very poor city north of Johannesburg. And I met him at a conference where they were talking about free software. And he was running a consulting service out of his house with dial-up networking because he felt that the government would not help them get the type of broadband they needed. He was conversing with Linus Torvalds, helping Linus fix a problem with the AMD virtual memory subsystem. And finally, that gentleman over there, he created his own distribution at the age of 12 and a half. At the age of 15, his father quit IBM and started working for him. His father had been in the industry for about 30 years. Today, he is 21 years old. He was named by Fortune magazine as one of the top 20 entrepreneurs, young entrepreneurs in the world. All of these people I'm showing you because they did what they did because of open source software. They were given the leverage of using open source. And of course, they had another advantage that they had accessible to them hardware at a low enough price that they could afford to innovate with it. Here's my latest hero. This gentleman was born in a favela in Rio de Janeiro. He pulled computers out of the trash can along with books to teach himself how to program. And at the age of 21, he decided that his favela needed an internet service provider with wireless services. People laughed at him. They said, no, they'll never pay you for the services. They'll take what you have and they'll never pay you. But eventually he ended up with a company that employed 6 people installing wireless services through his favela. He applied to the government for a grant and started a small one-room school for training people. I met some of these people from the favela. You could see the intelligence in their eyes. And Marcelo said to me, you know, MADDOG, they used to talk about guns and drugs, and now they talk about the internet and the web. The thing that is holding these people back is lack of money and lack of equipment that can help them develop the things they need. I have been coming to Brazil for over 20 years. One of the first trips I made here was to this university. I saw the first physical Beowulf system I had ever seen. I had heard about it, read about it, but here I saw it. And I saw what the university was doing with it. I saw great projects that were going on here at the university. And I also saw that the Brazilian lottery system had switched over to using free software which reduced the time to generate a new game from 10 months to 1 week. Do you know how much money you generate when you have a new lottery game available 9 months and 1 week early? A lot of money. A lot of money. So Brazil, I always thought of as the shining star of free software, or software libre. Now, about 3 years ago, there was a problem that was identified by the University of Cambridge. A lot of the students trying to study computer science coming into the university actually knew less about computers than the students of 20 years before. And the reason for that was 20 years before, a student would have an Amiga computer or a VIC-20 computer or some other little computer, and then they would have to go to the bulletin boards on the fledgling internet, dial into the bulletin boards and pull down the source code for the programs and get them to compile. And so the students learned about things like syntax errors and runtime errors. And maybe it was just bad typing on the magazine cover that you couldn't read the program you were typing in, but you knew that you could figure it out by looking at the rest of the program. And these were the students who later on generated the mainframe computers and the time-sharing computers and the Unix operating systems of today. But the problem that we're seeing today is that the student will buy a notebook computer or a desktop computer or some type of game computer like an Xbox, and on that computer it has the magic words, "If you open this box, you void the warranty." And so these students never look inside their computer. They don't see this made up of chips and disks and things like that. And they go and they buy a game at a store and they put it on the computer and they say, "Oh, I'm using the computer." Well, yes, they are. But they're not learning anything about it. They're not learning about how it works. And that's a problem. And they write some HTML and they say, "I'm a programmer." I'm sorry, you're not. And that's a problem. And so the university professors said, how can we solve this problem? And so what they did was they came up with the Raspberry Pi, a little $35 computer that said, hey, it's small enough to fit in your pocket. Well, maybe it's a large pocket, you know, but it's still a pocket type size thing. And it's cheap enough that almost anybody can buy it. $35 US. That's about 2 CDs of music, okay, if you bought the music that way. And they thought that at first they would only need 1,000 of these, you know, enough for their university students. And then all of a sudden they realized, well, maybe 10,000. And then, well, wait a minute, it's 100,000. Oh, it's 1 million. And to date, they've sold over 12 million of them at $35 a piece. Now, why is $35 so important? Because that was definitely a design consideration. It's because of these things, these little general purpose I/O pins here, that you then hook up to a prototyping board and you create things with it, you drive things with it. Robots and all sorts of neat things are driven off of those GPIO pins. But they have a problem, because if you plug the pins in the wrong way, then you blow up your entire Raspberry Pi. At $35, who cares? It's all right, you know, another $35, another 2 CDs. But if it was more money, you might be more careful. And if it was more money, you might not be able to afford it at all. So the problem in Brazil is something known as your import tax, your customs tax, your customs duty. You're all familiar with it. It's the thing which makes your electronics at least twice as expensive as everybody else, as every other place in the world, okay? And so if you take your Raspberry Pi, which sells at $35 US, and you then ship it to Brazil and you say you pay $20 for shipping, it's now $55. And because it's $55, customs doubles it to make it $110. And then you add local sales tax to that and also maybe a little profit for the people bringing it in. And now it's $150. How many of you have paid that type of price or have seen that type of price on the web in Brazil or in stores in Brazil for Raspberry Pi? I know you have because I have seen them. And if, however, you said, let's import those parts, let's manufacture it in Brazil, let's just take the parts and put them onto the boards, then all of a sudden the customs duty is 6% of the value of the product, of the parts, of the components. Now what does that do? Well, the parts of the Raspberry Pi are approximately $28 US. That's what you pay for the materials. $28 plus $20 in shipping would bring it to 48 times 1.06 is $50.08. It's still not 35, but it's a heck of a lot better than 110. It's half the price. And so we started thinking about this. I started thinking about this. How could we make this less expensive? Maybe we could do bulk shipping to reduce the shipping costs because that's how the government measures it. It's on the total value, the total cost. And I started thinking about the fact that there's 194 million people in Brazil, which is about half the population of the United States, and that's a fairly large market. So if we wanted to produce these inside of Brazil, we could actually do that. It would make sense. And then I met Professor Zufo of the University of Sao Paulo, and he showed me his surface mount technology machine, the robot that puts the parts onto the printed circuit boards. And he also showed me his laboratory. We had all sorts of equipment that could help to produce this, and he had lots and lots of students who were studying things like manufacturing and electronics and computers and computer science, and everything started to come together, along with the fact that the software that typically runs on the Raspberry Pi and other little computers like this is typically free software, software libre. And so this was another reason why I felt that I should help to bring this down. And I had certain insights. Everybody talks about the cheap labor in China. Let me tell you something. The SMT lines can produce between 5,000 and 10,000 motherboards a day, and they are a robot. The robot in China gets paid exactly no more money than the robot in Brazil, and vice versa. The robots get paid the same amount of money. However, the people that run the robots, and there's about 20 of them for every 8-hour shift, 3 shifts, 24 hours a day, those people are paid more in Brazil. But when you divide their wages over 10,000 boards, nobody cares. It's so small a difference that nobody will care. And so I started thinking about this. I said, this concept that everything electronic has to be made in Taiwan because it makes it cheaper is ridiculous. It's a fable. So why aren't things produced in Brazil? Why can't people in Brazil produce these type of computers? One of the reasons is it costs about $2 million to do the design work on a sophisticated single-board computer. You spend $500,000 talking to a company like Texas Instruments or ARM to get the license to talk with them, to get the information you need. That's just the way they work. And then with all the parts and engineering and everything else, you're probably going to spend another $1.5 million before you start to produce your first computer. Even if all the engineering work was done to take your design and put it on a surface mount technology machine, would cost about $100,000 to get it started. And while you're producing this on the surface mount technology machine, it is not producing other things which you could be selling and making more money. So there is a high risk of doing this type of work, and there's no real promise that you're actually going to be able to sell the computer that you design, nor you promise that you're going to be able to get somebody to port the operating system to your computer which you designed. And so a lot of the companies in Brazil that have surface mount technology machines, they produce memory DIMMs for PCs. They produce flash card or flash sticks, USB flash sticks, because those are simple things to produce, and they have a known market for them. However, they also have a very low markup. Their margins are very, very thin. So you have to produce a lot of them to make a real profit. So this all came together, and I said, if I could reduce the risk of these companies producing these computers and prove to them that there is a market, then they would go ahead and do it. Because 40 years in the computer industry has told me there's two ways you get somebody to do something. Either you make it so valuable to them and such a high return that they will climb Mount Everest to do it, or you make it so easy that they say, what the fuck? And they do it anyway. And so when those two things come together, that's the place that somebody makes something. So my goal was to make it as simple and low risk as possible to make this, at the same time show people that there was a market for this computer. So this is a picture of LSI Tech's SMT line. It shows the level of sophistication that they have in their facility. This was actually donated to them by LG. It is the same machine that LG uses to assemble their phones, their cell phones in Brazil. And LG keeps this up to date because every once in a while they borrow it back to do further testing and work on their own phones. Now, there are lots of little open computers. One of the most famous is the Arduino. Very, very simple little computer, completely open design. Anybody could take a little printed circuit board and put it together and buy the parts that are relatively easily obtainable and produce one of these. The problem is that it typically runs relatively slowly. It doesn't really have a real operating system. It's more of a data gatherer and primary processor of data. It might be an interesting thing to put out with your Internet of Things to do the initial data gathering, but it's not a real computer by my definition. But they are made in Brazil because it is so open and there is a market for them, and some people actually make them in Brazil and you can get them relatively cheap. There's the Raspberry Pi, we talked about it before. I'm putting it up there again because I want to show you several things about it. Number one, oh, there we go. Number one, it only has 512 megabytes of RAM. That's a relatively small amount of memory for a system. It has 10 100 megabit per second Ethernet. Why not gigabit per second Ethernet? It's because this only has a bus that has the speed of the USB 2, 428 megabits per second. And so it would not be able to drive a Ethernet faster than that. And it doesn't have any real I/O to it. It has a USB 2 port on it, which again is limited by the speed of the USB bus. So you have a really nice little computer. I consider this a nice little computer for a high school student to start programming on. But it's definitely not something that a university student would really be able to use. I contacted the Raspberry Pi Foundation. I have several friends actually on their board. And they did a lot of work to try and make the Raspberry Pi available in Brazil at a reasonable price. They went to Brasilia, they talked with the people in the government about having a special tax on the Raspberry Pi, and the government said, no. And we looked into manufacturing. Professor Zufo actually made some of them, returned them to the Raspberry Pi Foundation. Another gentleman in Curitiba did the same thing, and the Raspberry Pi Foundation looked at them and said, no. And so, and we think perhaps it's because there is an SMT line in Wales that are producing the Raspberry Pis now, and Wales is a UK country, and the University of Cambridge is in the UK. So naturally, they kind of want to keep their production and everything in the UK and not in Brazil. That's just my thinking on this. So then a little company called LeMaker came out with a better Raspberry Pi. It had a SATA controller on it, it had more memory, and it was maybe $5 more expensive. And I kind of liked that, and I wrote to them and said, could you produce these in Brazil? And they said, no. So I kept going, and in the meantime, I joined an organization called Linero, which helps to put free software onto ARM processors. And in this, I started to make more friends with more companies, and lo and behold, LeMaker joined Linero. And this gave me more access to them. And so I once again approached them and said, would you be willing to produce a Banana Pro in Brazil? And they said, no. So in the meantime, I met a gentleman in Massachusetts, Lexington, Massachusetts, at a company called Adaptiva. They produced a board which has a 16-core CPU on it. It has a field programmable gate array. And I said, finally, we're beginning to see systems which I think are worthy of a university student. This particular system costs $99. So if you brought it to Brazil, it would be over $300 for a Brazilian person to buy. So I kind of skipped over that one too. While I was working for Linero, they came up with a program called the 99 Board Program, which is a specification of how people build single-board computers. And the advantage of doing this is that you can mechanize a lot of the creation of the computer and reduce its price considerably. And so we started to see a bunch of designs of really nice little computers, very powerful, like this one, which has 8 cores, 64-bit system with 2 gigabytes of memory on it for $99 US. But once again, they were producing them in Brazil. And then I went back to the LeMaker people. I happened to go to China, and I was working with them, and they came out with a computer called the LeMaker Guitar. 4-core, 32-bit system running at 1.2 gigahertz, 2 gigabytes of RAM on it. It had USB 3.0, which is very nice because that gives you 5 gigabits per second. You can hook a cable up to it and convert that into SATA. And it had EMC memory directly on the board, which meant that it was faster than the Raspberry Pi, which took its access to its data through an SD card. All this thing, it was a little bit more expensive. It was $65 US, but it was a very nice computer and very balanced. And I asked them if they would produce it in Brazil, and they said, no. This is the example of the guitar. It comes with a COM board, a computer on a module, that has the memory, the CPU, the GPU, and the Wi-Fi, and on the back it has the eMMC memory. That sits into a motherboard. There's actually 4 of these motherboards with different capabilities. The first motherboard is called the B+, and that's where the COM board sits in a 204-pin DIMM socket. It has 10 100-bit per second Ethernet, USB 2 ports, USB 3 port, HDMI, and an SD card slot with infrared receiver on board, and 40 GPIO pins compatible with the Raspberry Pi Model 2 and Model 3. Very, very nice computer. And what you can do is take that COM board out and slip it into other motherboards. These motherboards are completely open, so you can design a motherboard to meet your needs. Please remember that for later on. So I met the maker people at CeBIT over in Germany. It's the world's largest computer and telecommunications show in the world. And I introduced them to all the people, to the Linero and all the open source people. A little bit later, I went on a trip to China and happened to stop by their offices. I met the founders of the company. We had a great time. They took me out to dinner and they said, "When are you going to start producing our computers in Brazil?" I said, "You told me no. 3 times you told me no." Well, that was different. We were a small company. We were busy doing other things, but now we got everything under control, so let's do this. That was last July. And when we started at the dinner doing the network calculations on the back of a napkin, we found out that yes, we would be able to produce the computers in Brazil for the same price as they're selling in other places in the world. So I came back to Brazil. And I started working with Professor Zufo for a long time of trying to work out the proper thing. And what we're going to be doing is buying the parts directly from the maker, the same parts that they use in making their systems. We will bring those to LSI Tech. We will start to produce them. LSI Tech is limited to 20,000 units because of their charter. They'll be able to make up to 20,000 units. After that, we will have a small company in Curitiba, Brazil, take over the production. They are going to be producing them at cost. I'll explain why in a moment. Then we're going to use existing distributors and resellers in Brazil, places like Arrow, Flippy Flop, others, that will then distribute those boards, and we will show them how to make money off of selling these boards at the lowest possible cost to the consumers. After we take the first board and turn it over to the company in Curitiba, we then bring in another design and start producing that. And so at the end of the year, I hope to have 12 different single board computers available with 12 different sets of capabilities, all being produced at low prices so that people can innovate and university and high school students can afford to have these. Now, we have additional parts to the plan of this. For example, because of the Mercosur agreement that says if 22% of the value of a product is added in Brazil, then all the other Mercosur countries cannot apply their import duties to it. Argentina, for example, has a 50% import duty on electronics. So we bring the parts into Brazil, we're tossed 6% import duty on the parts. We produce the systems, we sell them to Argentina. They can apply no import duty to them. So we can actually sell the machines produced in Brazil to Argentina cheaper than Argentina can buy them from Taiwan or China. We also have an agreement with the LeMaker people that if Brazil does innovation or creates something, that LeMaker will license it from Brazil and help to sell it in the rest of the world. And we have an open business model. We're not going to just rely on this one company in Curitiba to produce these systems. They may get the first system to produce, but we're looking for other small companies with SMT lines to build the other computers that we will be bringing into this marketplace. And we're looking for as many resellers and distributors as possible, which will help to formulate a capitalistic system where everybody is trying to innovate and keep the prices as low as possible in competition. We're going to start an Indiegogo program to raise the money for the parts, to produce the first systems. And of course, we're also going to have what they call perks in the Indiegogo program, one of which may be a nice 30-inch plush Tux penguin. Another thing might be a poster with Jimmy Tux on it, and because remember the computer is called the guitar, and also some mouse pads with Jimmy Tux at a lower resolution. So we will be using these in our Indiegogo program to attract attention. The Linero 96 boards program actually has two styles of boards. One is called the consumer, which is this size and costs less than $100. The other is called the enterprise board. It's a little bit larger and is directed at things like low-end servers, Wi-Fi routers, and things like that. And its target price is less than $300. And we want to be able to bring those into Brazil also using the same formulation. Over time, when we find that there are parts that we can find in Brazil, then we will stop bringing in those parts from China, and we will locally source the parts in Brazil, which will further limit or further reduce the amount of cost of producing these systems. This might be the second board, which is called the Maker High Key. It is the one that has the 8-core 64-bit system with 2 gigabytes of memory. And we would hope to sell that for less than $100 here in Brazil. Now, in addition to that, because of the Internet of Things, there's a whole series of sensors and nodes and things like that that go onto a daughter board that plug into the 96 board specification. So this will allow you to do the Internet of Things type of testing and type of innovation that you can do at the high school and university level by having these. This is a completely open design kit, so the whole thing can be produced here in Brazil. The Raspberry 2 Model B was considerably better than the Model A, but it still had some limitations. It was still only 1 gigabyte of RAM and still only had the USB 2.0 port. And so again, it's a kind of an unbalanced system for $35. Then they came out with the Raspberry Pi Zero, and everybody got excited because it was only a $5 computer. But by the time you added the communication devices, you added the power supply, you added the case and everything, it was back up to $35. And look at the amount of memory on it. 512 megabytes of RAM again. A friend of mine wanted to buy 20 of these and make a supercomputer out of them. I said, this is going to be the world's slowest supercomputer. And I recommend you take your 5 $20 pieces of money and stick it into this $100 computer and have 8 cores, 64-bit, and 2 gigabytes of RAM and see which one wins. So you have to watch these and you have to see which is good. Now, why am I showing you? Because this was all leading up to something else. Why am I showing you this? It's because as a hobby, about a year ago, I built this. It's a supercomputer in a briefcase, and it's built out of these little boards. And I could put this together for less than $400 in the United States. It has is really high capability. However, it's got some other interesting things you could do with it. You can actually use it to demonstrate high-performance computing. You can also generate high-availability computing. By putting different operating systems on it, including Windows 10 CE, you can show heterogeneous systems administration. And then you can carry this around to different universities and high schools and show people how to use them. I also, when I went over to China, I became familiar with the IEEE ACM computer science curriculum. And the Chinese wanted me to help them create a system that used only free software to teach all these courses, which we're in the process of doing. That led to creating what we call the curriculum in a box, so that you could take a box of little computers with some flash sticks to hold the data, to hold the programs, and to hold the instruction, and take that to remote places to teach real computer science to people. Oops. That's the curriculum in a box. On the left-hand side, oops, went past it. On the left-hand side is the box with all the components in it. It's just a cheap plastic box from the store. But then when you open it up, you find out that you have two computers, one of them an enterprise model and one of them a consumer model, one of them 64-bit and one of them 32-bit. And you can use them to teach client-server programming and networking and things like that. And you don't need a high-speed network connection because all of the data and all of the programming and all of the text is on the flash drives. You may have a low-speed internet connection to get a little bit of updates over the net from the last time you made the sticks, the USB sticks. And so we want to make these and get them out to high schools and universities, particularly in remote areas, so they can learn about computer science too. All of this gets better because Professor Zufo and I have been talking for a long time about making what we call a blobless computer system, one that has no binary objects in it whatsoever. You heard he has a project going, maybe one of the students talked about it here, of creating a GPU, a graphics processing unit, out of a field programmable gate array. And he's actually done that. They've actually produced some graphics with it. It's actually faster than the GPUs that came with the system. We want to be able to do that style of work here in Brazil. So that was us a year ago out at LatinoWare making the announcement that we were going to be doing this. And a year later, he is going to be starting the manufacturing of these systems in his lab so that by mid-October, the Indiegogo project will be online and people will be able to order these in any quantity that they want. So with that, I'll ask if there's any questions or comments or observations. Be happy to try and answer them. Oh, maybe this one. This one's on. I think it was on. Oh, no, okay.
You're talking about a $2 million investment for the development of a computer board. Can I suggest that you can use IEEE, this university, to develop a student competition to design boards? IEEE would provide funds for awards for the best results, and this can be a competition, let's say over 5 years, where we could refine it and come up with a really good, low-cost, high-performance design.
Who wants to start?
I will say that one of the reasons for going with this design where the COM board is there is that the COM board itself is a very complex design. The printed circuit board is 8 layers thick versus the motherboard that runs at a lower frequency and is much simpler is only 4 layers thick. So it encourages people to design different style of motherboards that they can plug the COM board into and get the computing power that they need. So yes, we would love to have competitions of design, particularly designing motherboards, later on designing other boards that we could manufacture. And one of the nice things about the university having their SMT line is that when people come along and say, I have a special need, the university could say, oh, here's a great design project for one of the students, and we have the line to produce the first 10,000 or 15,000 of them that you need. So it makes a perfect match in Brazil.
Questions, comments?
How institutions like FPF Tech and others in Brazil can have benefits for use this. If there's a model and we can use the same, like universities, because we are also providing innovation, and but we have the same problem to buy these boards and try to develop with low costs. So if there is some a business model for us, we can use this also.
Well, first of all, the output of this program, Professor Zufo is going to put together a special program for nonprofit groups. So universities or high schools which are nonprofit will be able to buy the computers at cost. So you'll be able to get them the cheapest you possibly could get them through the program. The Indiegogo program is for the general consumer. Now, a lot of people don't understand the entire amounts of money that it takes to generate some of these small computers. It's not only the materials, it's not only the SMT line, it's not only paying the people to run the SMT line, but what happens when we ship a computer to you and you get it and it doesn't work? You, of course, want your money back or you want another computer. So you have to send something to us. This is known as return manufacturer's authorization. It costs money to run that program. When you're running the SMT line and you produce 1,000 computers, you may find out that one out of the 1,000 computers is bad. Maybe you can repair it by hand. Maybe you can't. If you can't repair it, then the parts that went into that computer have to be spread across all the other units. So when you're doing this type of a program, if you want to make them the very lowest cost that you possibly can, you still have to build into the program the expenses for some of these things that people never see. We're trying to keep that as low as possible. But when we do this, we said we're going to have an open model. We will show people how to bring these systems in. And so if you really like a BeagleBone Black, if you can convince Texas Instruments to ship the components in, we'll be happy to manufacture BeagleBone Blacks. It doesn't make any difference to us. If you say, hey, I really like this other little computer, so we're going to reach out to other computer companies and say, yes, follow this model. It's okay. Reduce the price of your computers in Brazil so that more people can buy them, so more people can do innovation with them, so that Brazil can generate more interesting components. We want to do that. We're not out to make $1 billion. We're out to create innovation inside of Brazil. Did I answer your question?
Thank you.
We will do it, yeah?
Hi, thanks for your work and to bring affordable computers for Brazil. So I'm particularly interested in the education point of view. So for example, you showed your cluster of little board computers and that kit for teaching computer science. Have you been there testing or are teaching with using those, and how is that going?
The supercomputer which I built, it was a prototype, and it cost way more money than it should have because I kept going back and changing things and working it through. I'm going to come out with the beta version of the supercomputer, and that I will publish how to make and how to program. But I've been tied up with other things, including my heart attack, and I haven't had as much time to work on it as I thought I would. So again, I'll be happy to write up the article of where it is at this point, and if somebody wanted to work on it to take it further, that's fine. I've worked on a couple of other projects, one of which was a highly available supercomputer that would run off of solar batteries. And because I've been waiting for the little computers to be made here, because that would generate a lot more capability for a lot less money. So when we start producing these little computers, I will bring that back out again and show people how to make this solar-powered supercomputer that doesn't need any fans, that runs at room temperature or... That's another issue. These computers typically run at 40 degrees Celsius. And in a lot of places in Brazil, that is just too cool. We need something that will run at 70 degrees Celsius. And so one of the things that we can do as part of this program is go back to the parts manufacturers and say, we need parts that are industrial grade for certain types of projects. It may add $1 or $2 more to the board, that's all it is. But it has to be into the marketplace. So but with this program, we could do that because we have more control over the manufacturing than a general worldwide manufacturing program would. So, we can take people's unique needs, like 70-degree materials, and produce those too.
Just to clarify also, we just ordered with money from CAPES 32 of these boards to create a pocket supercomputer with 256 cores. So we'll have something like 32 nodes, 64 gig RAM, and 256 cores. But the machine will be the size of shoe box, and consuming less than 15 watt. So again, I have also some health problems, but this problem is already set and being sponsored by CAPES, the Brazilian funding agency for postgraduate studies. And another idea is making this machine available through the web. So people will be able to remotely program and configure the machine. One of the ideas is porting OpenStack. So we are even thinking about cloud computing these IoT devices. We call the fog, the low cloud, not the high cloud.
Hi, John. Good evening. You talk about some projects, but you have I think you have a project that's called Kawa project. Could you tell us a bit of it?
Sure. I'll try and make this brief because it is getting late. Project Kawa is a project which I started 10 years ago because somebody asked me the question, how do I make money with free software? Now, the answer to that in most cases is very easy. How do you make money with proprietary software? With proprietary software, if you're a consultant, you sell your ability to create solutions. That's what you're selling. Maybe if you're a systems administrator, you sell your ability to administer the systems and to keep them up. If you're a programmer working on an application, you sell your ability to write that program. And you leverage free software to give you the answer faster and better. There's one thing you can do with free software that you cannot do with closed source software, and that is you can actually change the software itself to meet the needs of the customer. And this creates a higher value of what we call return on investment of the software answer. I was talking with somebody at lunch today and telling them, you're sending billions of reais out of your country to pay for software for companies like Microsoft and Oracle, when you could be taking that money and paying young programmers inside of your country to create solutions for your people. And once that dollar or that real has left Brazil, it's gone forever, because there's only so much cachaça that Bill Gates is going to drink. Ballmer probably would have drank more, but Bill, he's pretty much a teetotaler, I know. So Project Kawa, but when I started to work on Project Kawa, I went beyond this. I took a look at Sao Paulo, and the density of Sao Paulo. Sao Paulo has a density 12 times that of Manhattan. 86% of the people in Brazil do not live in the rainforest, they do not live on farms, they live in cities, highly dense cities. And most people in the United States do not realize that Sao Paulo is the second largest city in the Western Hemisphere after only Mexico City. So I started looking at this. I started thinking about the amount of energy usage in Sao Paulo, because you walk into a lot of buildings and people have these electric space heaters on their desk. I mean, sometimes it's underneath their desk, sometimes it's here. And it's just kind of strange because Sao Paulo is a warm city. So why do you have this space heater on your desk? Oh, I'm sorry. You call it a computer system. But it's a space heater. It uses 350 to 450 watts for what? To type Microsoft Office. What a shame. And then the worst part is that for some reason you've never understood central air conditioning. You have all these little air conditioners up on the wall that take the heat provided by the PC space heaters and shove that out into the even hotter atmosphere outside. God help me. So I thought, what would happen if we replaced all those space heaters with little 5-watt computers? And what they did was a presentation of the information, and they captured the keystrokes, and they did all of that. And they lit up your 12 screens you've got in front of you. And that was what you had on your desk, only producing 12 watts of heat, or 5 watts of heat. And then down in the basement of these tall buildings, you had a server system that was expandable. You could keep adding CPUs and adding more memory and adding more disks, because these little devices were completely diskless. If one of them broke, you simply unplugged it and plugged another one in. And what if you made that server system and these little devices an actual part of somebody's business? You paid them to manage these systems and to provide the right software and everything for all the people in the building, whether it be a condominium or whether it be an office building with 40 small businesses in it. And that became their business. Those of you who have worked with distributed systems before know that one systems administrator can typically take care of 300 of these little systems if all of the data is actually kept in one place, if all the programs are actually kept in one place. And so you might find out that your systems administrator is only working 10 hours a week at doing systems administration, and they could be spending the rest of their time writing programs for their customers, running a specialized print shop, scanning shop, things like that. I put all of this together in a project called Project Kawa. And Project Kawa had nothing to do with free software, but it had everything to do with creating jobs. It had everything to do with reducing electrical utilization. It had everything to do with reducing the amount of digital waste that we keep throwing into our landfills every 3 or 4 years when we upgrade our computer systems. It had everything to do with creating a wireless, completely free bubble across all of the city of Sao Paulo. So when you walked out into the street, you simply turned on your Wi-Fi device and you were connected. That's what it did. But there was one problem. Because the most efficient time to put in the networking you needed into these buildings was when the building was being created. And then there would be a 2-year span of time until people actually started to move in. And what did that entrepreneur do in those 2 years? And then one day I had the problem solved for me because I had a friend of mine. Another interesting part about Brazil and most of Latin America is that the federal university system is free of tuition. So all the federal universities, you don't have to pay any tuition. God help me, I wish the United States was like that. Our students graduate hundreds of thousands of dollars in debt because we refuse to do what you are doing. But you also have private universities, and the government says, hey, we'll give out some free scholarships to deserving students to go for that. So, free federal universities, free scholarships for deserving students to private universities. 40% of the students who qualify for those universities cannot go to university. Why? Because they come from small villages outside of Sao Paulo, outside of Rio de Janeiro, and they have to move into the city. They have to find an apartment. They have to buy food. They have to have transportation. They have to have internet. They have to buy books. They have to buy computers. Very freaking expensive computers. So they can't afford to go. And some of these students who learned about computers at the age of 8, who have been fixing the computers for their family and for their neighborhoods for the last 11 years, not making any money, because how do you charge Aunt Susie for fixing her cell phone? But these kids cannot go to university because they're helping to make money for the family. They've been doing that since the age of 15. And if they go to university, that money stops, and the family suffers. This is why, in most developing nations, the oldest child never goes to university. The younger ones do. So I said, how can I fix this problem? And I found this one student in Sao Paulo that says, hey, I have a business. And what I do is I supply consulting to driving schools. Because they have all these computers and they don't know how to fix them. I go into the driving school for 3 hours each week and do whatever is necessary to fix their system. And he actually had a little contract that he had. And I said, wow, what a great idea. Let's expand this. Let's make this work. And so we put together a more formalized contract. We put together advertising materials. We put together a program of how to line up first-year university students who need money with small business people who need to know how to use their computers. And the students work 3 to 4 hours a week for each company, and they get 6 companies as business. So that's 24 hours a week that they're working, and the rest of the time they go to school. This is much better than flipping hamburgers for McDonald's, where you don't get paid, you get paid miserable money. Because you can make, at this job, about $1,000 US a month in your spare time. And yes, it might take 6 years for the student to get their degree because they're taking their courses at a slower rate. They're working part-time and going to university part-time, but they will get their degree. And they will learn how to run a business. And they will be able to sell their business as a senior to an incoming freshman who will take it over. And so they will walk away with some money in their pocket, which McDonald's does not give them. Now, what about my tall buildings? How do we do that? As the students are coming in, when they get to be a sophomore or second-year student, I come to them and I say, go find a building that is being built, talk to the architect, tell them how to put in the networking they need to put in. And 2 years later, when you graduate, then you'll be able to buy your server systems and your thin clients as the building is populated with people. So in the middle 2 years, in the 2 years while the building is being built, the student is getting their degree, and they're also earning money with Project Gawa. Now, this all works out on paper, but there was one little problem we still had to solve, and that's the fact the students don't think they know anything. I taught at university for 4 years, full-time. I would teach my students, I would take them, they'd never seen a computer keyboard. I took them from never having touched a computer keyboard to being able to write compilers and operating systems in a 2-year period of time. And they would come to me in the last couple of weeks before they left the school and they would say, Professor Hall, I don't know anything. What do you mean you don't know anything? I don't know it. I don't feel I know anything. How many of you felt that way in your undergraduate degree? You got to the end of the degree, you said, I don't know anything. I can't possibly be any, well, maybe not this group of people. A lot of them do. you feel you don't know anything. Well, remind you that when you go home and you talk to your parents and they say, what did you learn today? And you say, oh, I learned about this and this and this and this. And they just sit there like this. And after a while they say, please pass the rice and beans. You know something. It's valuable. It's just you have to find out what you know. And you have to have that faith in yourself that you can go out and sell yourself to somebody else. And that's what was missing. We needed somebody to give these students faith. And that's when I came up with the idea of the Hacker Center, the Make It Center, the Alumni Association, the people with experience who'd be willing to take one of these students and mentor them and walk them through the process of finding that first customer. Because you only have to find the first customer. You may have to talk to 100 people to find that first customer, but when you've made that first sale, the world opens up for you. And so, individually, we have to show the students what they know. Individually, we have to take the students to make that first sale. And then after the students have been making their first couple sales, they become the experts, and they take the next student. They mentor the next student. And so, again, we're getting the little computer system started. That's the first priority. The second priority is to kick off Project Kawa in a big scale. In Rio de Janeiro, in Sao Paulo, in Manaus, in Curitiba, because it is immensely parallelizable. There's nothing that would stop it once we get it started. And so that's the plan. I have one final project I'm working on. It's called MADDOG's Monastery and Marina of Math, Music, Microcomputing, Microbrewing, Microwinery, Microdistillery, and Bait Shop. After all, if you have a marina, you need a bait shop. And that's my retirement project. If you want to hear about that, you'll have to come to the barbecue tonight. Thank you very much.
Special thanks from the Consumer Electronics Society. Thank you so much. And a warm applause again.
Experience the options of your choice. The Linux operating system. The Linux operating system.